In this video, I'd like to walk you through the configuration of connectivity between the outside physical world and our NSX internal routed environment. And for that connectivity, that is also very much like DHCP, that is also going to involve the services of one of our edge transport nodes or even a pair of edge transport nodes to provide that functionality. So to implement our external connectivity, we're going to leverage our existing topology, which we put together in our previous video. And this time, we're going to take our tier 0 gateway and we're going to give it an additional interface or two right here to connect to an external network. So in my home network, I've got this 192.168.1 network, and off of that network, I have a default gateway at .1 that goes off to the external world with things like NAT and everything else. And so what I'd like to do is leverage that network right here. This is the 192.168.1 network, and my default gateway on my real home network here is .1. And so what I'd like to do is I'd like to configure NSX to provide the connectivity between these VMs right here in the NSX routed environment to the outside world. So to pull that off, there's a few components we're going to implement. One is I'm going to create a segment, an NSX segment that represents a VLAN. And this is called a VLAN backed segment. Think of it like an NSX network that's mapped to a specific VLAN. Now, in my case, this network right here has absolutely no 802.1q VLAN tagging whatsoever. So I'm going to refer to this VLAN as VLAN 0, basically telling NSX, hey, no tagging involved, just send the traffic right through. So I'm going to create a VLAN back segment. I'm going to call it net 192. And when I create that VLAN back segment, I'll specify that the VLAN associated with that segment is 0. So we're going to have this logical segment that's sitting there in space. And then secondly, we'll go ahead and we'll connect our tier 0 gateway, this one right here, to that segment. And we'll give it an IP address. So because this is my 192.168.1 network address space, let's use .38 and .39. You might say, well, Keith, why would you use 2? And the answer is we have edge nodes, edge 1 and edge 2, that behind the scenes are going to be providing that external connectivity. So if we use .38 and associate with edge 1, for one of the interfaces on this tier 0 gateway and .39 for the other interface using a separate edge node for that, then we can have some fault tolerance. And if we want to, we can also set up a virtual IP address on that external interface of .40 or some other address that's available. So based on what I currently have available on this network address space, I'm going to go ahead and use .38, and we'll associate that with edge 1 to provide that function, and .39, and we'll use edge 2 for that function, and then we'll set up a virtual IP address of .40. So behind the scenes, it's not host transport node A or host transport B that's providing that external link. It's literally going to be one or two of our edge nodes based on how we configure them to support external interfaces on this tier 0 gateway. So we'll create the VLAN back segment representing this network. We'll connect our tier 0 gateway to it via two of the edge nodes. Third, we need to set up routing as well. So just because we're connected to this common segment doesn't mean our tier 0 gateway believes that it should use .1 as its next hop to reach the internet. So we'll set up a default route for IPv4, and for that default route, we'll simply tell the tier 0 gateway, hey, if you ever need to get to routes that you don't have a more specific route for, use .1 as your next hop for the default route. And if we want this VMA1 to be able to go out to the internet, unfortunately, this router at .1 has no clue about how to forward packets down to the 10 address space. And also, we don't want to be sending traffic out on the internet with a source address of 10 anything, because that's a private RFC 1918 address space. So the additional piece we'll want to do right here at our tier 0 gateway is network address translation, specifically source NAT. And that way, any traffic that comes from the 10 address space as it tries to go through our tier 0 gateway and out to the external router, we can go ahead and we can net it over to one of our existing IP addresses or some other IP address that's available. So let's net it over to .40, and we'll also be doubling up and using .40 as a virtual IP address associated with this tier 0 gateway. But it could be .38 or .39 or some other available IP address on this common segment for the source NAT. Now, let me also reinforce one important aspect, and that's this. In this series of videos, my goal is to walk you through step by step the ability to create a nested lab environment that involves vSphere and NSX, and also to verify functionality, that it works. And that's my intent in this video as well. So if you want a deeper dive and a slower pace as far as the individual components and how to set them up and all the details regarding how NSX operates, I once again invite you to consider checking out our content over at CBT Nuggets, where we do a full step-by-step walkthrough of each and every one of these components in a more moderate pace. While in this series that we're currently in, my goal is to walk you through setting up of a nested lab so you can get hands-on practice, and also at the same time to validate that what I'm walking you through actually works. So with that being said, our next step right now is to go ahead and implement the external interfaces from the Tier 0 gateway that connect to my 192.168.1 network for the benefit of connectivity out to the internet. We'll also set up network address translation in our routing, and then we'll test it to make sure that it all works. All right, so our first step is to create a network segment, a VLAN backed segment that's going to represent my 192.168.1 network. So to do that with networking selected, I'm going to click on segments, and then here in the segments section, we'll click on add segment. And I'm going to name this net 192. Now we have two options for the types of segments. One is we can specify based on the transport zone of an overlay based segment. And if that was the case, we'd choose this right here. Or if we want this new network segment to be based on an existing VLAN, we can go ahead and click right here, nested VLAN transport zone. And that's how it determines, is this an overlay segment that can be extended across, for example, multiple ESXi hosts, or is it an NSX segment that's mapped to a specific VLAN? So in our case, we want it to be a VLAN-based network segment. So because we specified it is VLAN-based, it's also asking us down here, what is the list of VLANs that you want this mapped to? So in our case, I'm going to put a 0 here because my 192.168.1 network is my native VLAN. There's no 802.1 tagging going on whatsoever, and that's what that indicates right here in NSX. If I wanted this segment mapped to, for example, VLAN 20 or VLAN 30, I would put the respective VLAN right here. So with the name specified, and with the transport zone specified and the VLAN specified, it's a temptation right here to go ahead and say, hey, let's connect this to Tier 0 Gateway 0. But the way we're going to do this is, first of all, create the segment without assigning a specific gateway. So we'll click on Save right here. So now that segment exists. And then the second step, after we click on Close Editing there, the second step would be to go to the gateway itself. So we'll go to Tier 0 Gateways, and we're going to edit the properties of our Tier 0 gateway. So we'll click on the three dots, click on Edit, and then from here, we're going to go down to Interfaces and GRE Tunnels, and we're going to click on Set right here. And by clicking on Set, we can then specify that we want to add one or more logical interfaces that are associated with that VLAN back segment that we just created. So to do that, we'll click here on Add Interface. And I'm going to name this E1 just to remind myself that I want to associate this logical interface on our Tier 0 gateway with Edge 1. I'm going to say 192, referring to the network. And then I'm going to go ahead and put in .38. And that's kind of a wacky name, but that way when I see it, I'll remember, hey, this is Edge 1 on the 192 network with the host address of .38. And then here I'll specify the real address I want to use, which is 192.168.1.38 with a 24-bit mask. And then I want to connect this to that net 192, which is a VLAN-backed network segment in NSX, which is mapping over to VLAN 0, which effectively is my 192.168.1 network. And then for the edge node, I want to go ahead and choose Edge 1. So this Edge 1 is logically providing this logical interface on our Tier 0 gateway that's connected to my 192.168.1 network, and it's going to be using this address of .38 to do that. So we'll scroll down, click on Save, and then we'll add one more. So I'm going to go ahead and highlight that syntax right there because we're going to repeat that for Edge 2. So we'll click on Add Interface, I'll paste in, and I'll change this to Edge 2, and we're going to be using the address of .39 based on our plan. And here I'll put in the full IP address of 192.168.1.39 with a 24-bit mask. And then it's going to be connecting to segment net 192. And then for the edge node, it's showing us the remaining edge node that we have, and that's Edge 2. So we'll select that, and then we'll scroll down and click on Save. And now we have two logical interfaces on our Tier 0 gateway, both of which are connected to my 192 network. So we'll click on Close and scroll down, click on Close Editing, and then let's go ahead and take a look at the topology. So if we click here on Network Topology and we zoom in, here it's showing us that from our Tier 0 gateway, we have two interfaces, and they have the addresses of 192.168.1.39 and 192.168.1.38. This one is being supported by Edge 1, and this one's being supported by Edge 2. The other thing we wanted to do was use a virtual IP address as well, using .40, and it's really easy to do that. We'll simply go to Tier 0 Gateways, we'll click on the three dots to edit our tier 0 gateway. And here in the editing for our tier 0 gateway, tier 0 gateway 0, for HAVIP, for virtual IP address, we'll click on set, and then I'm going to click on add HAVIP configuration, and I'm going to specify the IP address of 192.168.1.40, which is currently not being used on my network, so I'm going to go ahead and use it with a 24-bit mask, and then we're going to specify the two interfaces for the purposes of HA, which can support that. That way, if we lose one of our edge nodes, the other one can continue the party and still provide functionality for that virtual IP address. So for the edge node interfaces, we'll use edge 1, 192.138, and the other logical interface to support this will be edge 2. And those are the labels that we gave to those two logical interfaces, which are again being supported on the back end by our two edge nodes. And we'll click on add. And then we'll click on apply and click on save. And scroll down and click on close editing. All right, then we'll collapse everything. So let's look at our game plan. We created a VLAN back segment to represent network 192. We then took our tier 0 gateway and we added two logical interfaces using .38 and .39. We also set up a virtual IP address of .40. So before we set up a default route, it'd be wise just to verify that using those interfaces that we just configured on the tier 0 gateway, just to verify that they can actually reach this external router, which is at 192.168.1.1. And the easiest way to verify that is simply to SSH over to one of our edge nodes, and from the edge node, if we can ping, from the correct VRF that is, if we can ping that 192.168.1.1 address of our external router, that just helps us reinforce that we have the connectivity and that our external interface is good to go. So let's take a moment and do exactly that. Let's SSH over to .36 over to edge 1. So here we are, SSH'd over to edge 1, and we'll type in get gateways and press enter. And for our tier 0 gateway 0, there's the services router. Let's go into VRF7. So we'll type in VRF7. So logically, it's like us sitting in this little mini-me version of the router, the tier 0 gateway 0 router. So if we did a get forwarding right here and pressed enter, it should show us the routing table, including the fact that we are directly connected to the 192.168.1 network. So we should be able to ping the default gateway right here from this VRF of our external router. So we'll try to ping to 192.168.1.1. And if this works, oh, that'd be great. And it is. So that just verifies we have basic connectivity between the logical tier 0 gateway with the help of our edge nodes and the external router. So now that we've verified that, let's set up a default route that says to this tier 0 gateway, hey, listen, if you don't have a more specific route in your routing table, go ahead and forward the traffic to the next hop of .1, which is my external router. So here in the NSX manager, with networking selected and tier 0 gateway selected, we're going to edit once again the properties of our tier 0 gateway. So if we click on the three dots, click on edit, and then scroll down to the routing section, and then we'll go down to static routes. Now this also supports BGP and or OSPFs. However, in this case, in the lab environment, I'm simply going to use a static route. So we'll click here on set next to static routes, and we'll click on add static route. And then we can give this a name. We'll call this default, call it anything you want. And then for the actual syntax, the syntax for an IPv4 default route is 4 zeros like that, /0. Just like that. And then for the next hop, we want that to be 192.168.1.1. So we'll click here on set, and then we'll click here on set next hops, and we'll do 192.168.1.1. And I'll leave the admin distance and the scope defaulted, and click on add, click on apply, click on save, click on close, and then finally click on close editing. And let's go back to the CLI for our edge node just to verify that default route shows up and that it's working. So here is edge 1 where we left it. So previously when we left it and looked at the IPv4 forwarding table, there is no default route there. It would be right above this one at the very top of the list because it's all zeros. So now that we added a default route and we're in the VRF for the services router for tier 0 gateway 0, let's hit the up arrow key a couple of times. I'll do a get forwarding again. And this time, here is our default route. Fantastic. It is showing up. And because on my external router, I also have NAT set up, we should be able to, from this VRF, to ping something out on the internet like 8888, and that is working. Now, the reason that's working is because we have a default route that says, hey, if you don't know how to get to a specific network, forward it to 192.168.1.1. And just to confirm there's not magic involved, this gateway right here, this router, this external router, which is at .1 on the 192.168.1 network, it also has source NAT set up. So it's translating any traffic source from 192.168.1 anything into a globally reachable address. And that's why the ping that we're doing from the VRF here for the tier 0 gateway, that's why that's able to go out to the internet and get a response back. However, that's not really going to help out our VM down here, A1, because as it sends traffic out, that traffic is going to be sourced from the 1010 address space. So we also need to set up NAT here on our tier 0 gateway that says, you know what? If any traffic is being routed through and it's coming from a source address of 10 anything and it's going out to the internet, let's go ahead and do source address translation. And because we have the virtual IP address of .40 already in place, let's just do source NAT to that source IP address. So back to the NSX manager and back to the tier 0 gateway we go to implement network address translation. So for the network address translation here in NSX manager, we'll once again go to networking on the top, and on the left under network services, we're going to go to NAT. And with NAT selected, and it's very important we select the right gateway, and with our tier 0 gateway selected, we'll go ahead and click on add NAT rule. So I'm going to go ahead and call this our source NAT. Let me make a little more room here. So I'll call it our source NAT for the type. It'll be source NAT. On the initial flow, we're swapping out the source address. And for the source IP address, let's say anybody coming in from 10 anything. So that's how we represent a source, first octet of 10. The rest doesn't matter. And going out anywhere, we'll leave that blank so it matches on everything. And the translated address we want to use is going to be our VIP address, which is 192.168.1.40. And then we want to apply that. And we can specify exactly where we want that to apply to. I'm going to choose these two interfaces, or if you left this off, it would automatically apply to those. But I'm going to be very granular and say, you know what, these two interfaces, which are our two external interfaces on our tier 0 gateway, that's where we want to apply the NAT rule to. We'll click on apply, and we are set. So effectively, once we save this, any traffic sourced from 10 anything going anywhere, if it's going out either of those two external interfaces, we are going to swap out the source address with 192.168.1.40, and that looks good to me. So we'll click on save, and that looks like it took. Fantastic. So let's go back to our topology view. So we'll go down to network topology, and effectively what that means is that we should be able to take one of these VMs. Let me go ahead and expand that. Let's go ahead and take A1. Now with A1, it's a DHCP client. It got an IP address via DHCP services. It knows that its default gateway is .1 on the 10.10.0 network, and these tier 1 gateways have been configured when we deployed them to advertise directly connected networks up to their tier 0 gateway. So tier 0 gateway knows how to get down to the 10 network address space. And on our tier 0 gateway, we've configured network address translation. We also configured a static default route using the external router at 192.168.1.1. So if everything is correctly configured, this little VM should be able to access the internet. In fact, for a little bit more fun, let's, instead of using A1, which is a really small and limited machine, let's use our Mint Linux device, which is a fully functioning Linux computer and has a browser and other features that we can test as well. So as a test, let's open up a remote console to our Mint Linux VM. So to do that here in the vSphere client, let's go to VM and templates view. There is our Linux device right there. I just want to confirm that it really is on segment 10. It is. Fantastic. So we'll power it on. And then as it's powering it on, we'll also go ahead and launch a remote console over to that little VM. So here is that VM right here. And I also want to just confirm that it's a DHCP client. If it's not, we'll modify that as well. Let's do an ifconfig. And 10.10.0.50, that's one that we statically configured because the DHCP range we set up was 151 through 200. So let me just modify its networking config just for a moment. And that way we can verify everything is working as a whole. So we're going to edit the networking config, go to IPv4 and say we want to use DHCP, click on apply. We'll close that window. And then just for good measure, I am going to reboot this VM. And that way we'll have a nice, fresh, clean start. So we'll click on restart and its reboot is underway. So we'll give that just a moment to fully initialize. We'll verify its IP address and then we'll verify internet connectivity as well. All right, so there it is. Let's bring up a command prompt. And let's do an ifconfig. So there we go, 10.10.0.152. Let's do a ping. In fact, let's do a trace. We'll do a trace -n out to 8.8.8.8. And yeah, that's going great. Fantastic. So this just verifies basic connectivity out to the real internet and not something in my home office. And let's bring up a browser. And let's go out to fast.com. That's a speed test from Netflix. And there's our speed test results. Fantastic. So we've got connectivity out to the internet. And let's also go to YouTube as 1 second check. And here's our connection to YouTube. And that looks like it's working great as well. All right, fantastic. I'll close that, minimize that, and let's review. So we implemented a VLAN back segment We leverage that VLAN back segment to create two logical interfaces here on our tier 0 gateway, leveraging Edge 1 and Edge 2. We also set up a default route pointing to our external router. We also set up network address translation right here, so that when this client, or any client on segment 10 for that matter, is going out to the internet, not only is routing in place, but we also have network address translation here. And as I mentioned, there's also network address translation happening here at my physical router that says anything coming from the 192.168.1 address space, including what we mapped over here at .40, should go ahead and be translated into a global routable address before sending it out to the internet. And then on the reply back, we're untranslating here and also doing an untranslate here before that traffic is forwarded back to the client. It's also important to remember that behind the scenes, these external interfaces and that connectivity to the external world are being provided by our edge nodes. And another way of verifying that would just be to go into NSX Manager, do a trace flow, for example, from one of these machines down here on either of these segments out to the public internet, and that would show exactly which edge nodes are involved. In fact, because it just takes a moment, let's just confirm that together right now. So here in the NSX Manager, we'll go back to Plan and Troubleshoot. On the left, we'll select Traffic Analysis. We'll clear our previous trace and do a new one. And let's go ahead and do a test from our Mint Linux computer, which we just used a moment ago. There's its IP address. And instead of having the destination be a VM, let's specify we want to use an IP address. We'll do layer 3 only, and let's target 8.8.8.8. So that way NSX will confirm the flow of traffic from this VM as it goes through the NSX environment out to the next top default gateway. And this as far as the NSX is able to track it, because anything past our default gateway is outside of NSX control. So we'll click on Trace, and the expected traffic flow would be from ES6IA going to the active edge node. So here is the traffic flow. So starting off on ES6IA, who then forwards it over to Edge 1, and Edge 1 is doing the processing of the logical routing and the edge firewall, and the connectivity up through the tier 0 gateway, including the logical processing of the NAT, which at the end of the day is in the background being done by our edge node. And then past that, we're handing it off to our default gateway, and then it's off to the rest of the physical network and the internet and so forth. So again, the traffic analysis through TraceFlow is a fantastic tool to help confirm which nodes are being used and also whether or not traffic is successfully making it through the NSX environment.